let's see. Table 5, you can have your point too. And 4, get you another point. Yeah.
What if it was
It's not for my class, and we were in math. Is that my class? I've given out a Quizlet?
Yeah.
So do I care about it? No offense. No. Were you supposed to be doing something for me? Absolutely. Okay, so all the things you were supposed to do for me, you've already done, right? Oh, terrific. Then let's go over number 3. I need help. Is there a GCF that you can pull out of number 3? There's more than just that, right? Yes, you can pull out an A, but it should be more than just that. Does 9 go into 26? Does 6 go into 26? Okay, so what number goes into 26, 18, and 32? 2. So let's factor out a 2A. I'm going to have to do it down here because I got some ugly stuff right at the top. What would be left if we factored out a 2A? 13 what? Plus what? Plus what?
16A.
Beautiful job. Beautiful. Everyone kind of helped, so I don't even know who to get the point to. I'm kind of hoarding the points today, so I'm just going to save it inside then. Let's do number 6 next instead of number 4. Oh, you want to do 4? Okay, let's do 4. My bad. I'm changing my mind. Let's do 4. Okay, number 4. How many terms are there?
4.
There are 4 terms, and so we need to back up to number 3. We discussed yesterday there were some rules. If there are 4 terms, yes, GCF, but then we have to think about can we do grouping, and we could not because now we're down to 3. There's going to be a time where from here we'll be able to factor, but on this one we can't. We actually have one today that's going to get a little complicated. Okay, 2 of them really. Number 4, how many terms are there?
4.
Okay, so I'm assuming Ellie tried to pull out a GCF. Was there a GCF?
Yeah.
What was it?
21.
21 pulled out of everybody?
Yes.
21 pulled out of 15?
No.
3.
Yeah, I think 3. So if you have 3, then what would be left? And I'm going to, and it's 7K to the third? Because I can't pull out a K because that last term doesn't have a K. Okay, a point to whoever can tell me what the rest of it that's left.
Minus 28k squared plus 5k minus 20.
And Paige got her group the next point.
Yeah.
Okay, are we done? We pulled out the GCF. Every other problem we've been done after we pulled out the GCF. What's different about this one? There's 4 terms, so what can we do? Let's try grouping. So we're going to put parentheses around the first 2, parentheses around the second 2. We're going to see if there's something we could factor out. And I'm going to keep using these giant back brackets just so everyone understands 3 is not involved in this situation. Okay, so 7k to the third minus 28k squared. What can we factor out of those 2 terms? 7 what?
7k squared.
7k squared. And what would we be left with? And then what? Minus what?
4.
Okay. And so that's from the first term. So I saw they had a 7k squared in common. I factored it out. I was left with k minus 4. But again, that's still just for that first term. So for the second term, 5k minus 20, what can I factor out of it?
You can pull up the 5.
And what would you be left with? Okay, and I am happy. Why am I happy?
Because they both have K minus 4.
They both have k minus 4. So my final answer would be what?
7k plus 5, k minus 4.
But don't forget about that 3. So the 3, I've just been bringing him down this entire time that Ellie factored out to begin with. He didn't go away. He just wasn't part of the grouping process. So the 3's still there. We have 7k squared plus 5, and then we have the k minus 4s. Perfect. Are there any questions about number 4? Number 6 is also ends up being a complicated one. Interesting. So let's go to number 6. What factor could I pull out of number 6? 5. Okay. Paige is right. And I'm going to give Paige a point for that. Why is 5 the smallest number? Why is 5 the only number besides 1 that we can factor out of number 6? They all are divisible by 5, but I was trying to do a bigger one. I thought maybe 25. Which term is not divisible by 25? Which one's not divisible by 25?
75.
105 is not divisible by 25. There's an issue with that one. And then I tried to do, someone last period said 35. 35 is not going to work. 35 times 2 is 70, and I have 75. So that's not going to work either. The biggest number that divides into all three terms is what Paige said. It's 5. So we factor out a 5. What are we left with?
21
Paige got herself another point. Ryan and Nick are glad they're sitting with Paige today. Are we done? How many terms do we have? So we can try grouping. So let's see, group those, group these. I'm going to still bring down that 5. What can I pull out of? And what would you be left with?
3 and minus 5.
Minus 5?
Plus 5.
They were both positive, so it should be a plus 5. We'll give your group a point for that anyway. So we looked at this term. 21n cubed, 35n squared. We pulled out a 7n squared. We're left with 3n plus 5. Now we've got to think about the second group in our grouping method. What can we factor out of negative 15n minus 25?
Negative 5.
So 5, yes, but wouldn't it be better to do a negative 5? Okay, so we factor out a negative 5. What are we left with?
3n minus 5.
Is it 3? She said 3n minus 5.
3 and
Plus 5.
It actually is plus 5. Negative 5 times positive 5 is negative 25. I was almost sad because I was with Paige. And I was almost sad, but now I'm happy again. Why am I happy?
Because we have to
Because
they're the same.
3 and 25.
Yeah, the 3 and plus 5 match, so I'm happy. So my final answer would be,
5, 7n squared minus 5, 3n plus 5.
and you got it all the way out so you can add the point. 5, 7n squared minus 5, 3n plus 5. Okay, and this doesn't seem very nice. I get that. But again, we're trying to factor, and eventually this would help us get to an answer faster. I know it still looks just as complicated as the problem itself, but it helps us reach answers faster when we're able to factor. Good Lord, all the F's. Okay, any questions about this? I do not have your test graded, but I was grading through first periods and they kept making this one mistake. So when I get done rambling today, I'm going to look through yours and see if anyone made this major mistake. And if so, I'll let you fix it, because God bless you, you had a blonde moment. Okay, let's talk about this major mistake that I saw on first period papers. It was the graphing inequality problems. They had a coordinate plane. Good for them. They graphed the line. They even paid attention to making it dotted or solid. They did that. And that's their answer. What's wrong? They didn't shade anything. So I'm gonna check your papers and make sure you people shaded. Why did they not shade anything? I don't know. I don't know what happened, but my gosh, you gotta shade something. Okay, you have a new giant packet of notes. Let's talk about that, because it is a little depressing. So let's talk about how depressing this giant packet of notes is. Not just because it's homecoming week, and not just because it's a math class, but because, sadly, this packet with all these pages is just 2 lessons. It's just 3-1 and 3-2. This giant heavy packet is only 2 lessons. 3-1 and 3-2. 3-1, 3-2, and I think maybe a tad of 3-4, but no, really it's just 3-1 and 3-2. In fact, we're going to stay in 3-1, and 3-1 has so much stuff in it that we're going to take a test just on 3.1. Not a chapter 3 test. Oh no, we're not going to make that happen for the end of the 9 weeks. We are not that good. But before the end of the 9 weeks, which means one day next week, I'm hoping it would be nice if it was Tuesday. That way we can get those retests in. But yeah, it'll be okay if it's not. I'm hoping next Tuesday we'll get to take a test on 3.1. Just one section. Yeah, just one section. Just one section. Oh, and that reminds me, if I have some who have missed a test and they gotta come get it together, you know, next week's the end. It's the end of the 9. You gotta get your life right. Yeah. This is week 8. Next week's week 9. And then there's something else important that I need to say that I forgot to say. Since next week is pretty much it for us, what did we discuss is going to happen every 9 weeks with these math workshops?
Oh, it's that.
There is a math workshop test. I'm going to tell you right now, it is next Tuesday. I know that one's next Tuesday. I'm not moving it. Next Tuesday, there was math workshop test. Will Paige get to use her math workshops on the math workshop test? No. Our plan was for no. Paige is actually supposed to, I don't know, have paid attention in class, which she has, understand the concepts, which she does. So when she sees a factoring problem that's different than the ones we've done, but it's very similar to, she should be able to handle it. Similarly, maybe there's a problem like the ones we're going to handle tomorrow where we simplify the radicals. She should be able to handle that. This is not our first time to see this kind of a problem. She should be able to handle it. On Monday, I will be nice, and I will be more specific about which problems in your math workshop I think you should study. But regardless, my gosh, Paige has, I think, if this is week 8, that means she's got 8 pages of 8 math workshops. She could study at any time. She's that good. It's just 8 different pages. Yes, dear.
We don't get to use them this year.
No.
Maybe.
No.
Wait, hear me out. Hear me out. All right. What if?
I'll discuss it with all the other math teachers, but we're all doing the same thing. And at the moment, we all vote. We all vote. And I am not a rebellious one. I'm the opposite of
What
rebellious.
if they don't know though? What if
I'm
they-
a rule stickler.
What if they don't know that?
The internet knows at 11:21 that we had this or 11:21 into the recording that we had this conversation. The internet knows, Jesus knows, I know. No. Okay. So, moving on from mine and Cooper's distracting selves. Let's see. So, new chapter. So you and Piecewise are done for now. So that sounds nice. And we're moving on to something that, again, you weren't supposed to have learned Piecewise in Algebra 1, but you were supposed to learn systems of equations in Algebra 1. Your teacher spent a long time on graphing, substitution, and elimination. Now, you had geometry last year. 2 years ago when you took Algebra 1, you did substitution, elimination, and graphing. So, yes, we're having a refresher so we can figure it back out. But this is not the first time Cooper's seen this. He's seen this before in his life. It's just been a while. Okay, so today we're going to just do graphing. We're just graphing. Tomorrow we're just doing substitution. On Friday, there will be a checkpoint on graphing and substitution. Graphing and substitution. Okay, we're only doing 2 pages of notes today. One is page 1, the other is page 2. It's in your new packet. Let's flip. Your homework is 3 problems from your workbook. I know. I'm the worst. Your homework is 3 problems from your workbook, which we haven't used lately. So I understand if you left it at home, but get it together and it's 3. 3 problems. Get them done. Okay. Second drawer? Okay, so let's look at this one. They're supposed to be. I don't know where my stuff goes. It's where it's supposed to be. I see one on my desk. There's supposed to be a black one over here. There's supposed to be one of your second. Yeah, that's the one.
Let's just do this.
No, I don't know. It's supposed to be. I can't help what children take from my room. That's their own fault. I'm not Santa Claus, so I'm not going to produce more stuff. Let's see. So, Cooper's got me way distracted today. It's fine. I'm going to put a star by the vocab, and that's my way of telling Paige that this is on the test. So I've already seen the 3.1 test that we're going to take, and the first little bit of it is vocab. Do you understand? And we're about to learn 4 really good, important vocab terms. And those 4 are going to be on the 3.1 test. So the first one is not going to be. It's just what we're studying right now. We're studying a system of equations. Okay, so a system of equations is 2 or more equations with the same variables. So if we look at problem 1, they have x's, they have y's. They have x's, they have y's. They have to have the same variables or we can't solve the problem. They have to have the same variables. Okay, and then the next thing says systems of equations can be classified by the number of solutions. How many solutions could something have? Well, with absolute value we were saying 2, but with us we're going to either have 1, we're going to have none, or we're going to have infinitely many. we're going to have one solution, no solution, or infinitely many solutions. Those are going to be our three options solution-wise. But sadly, we have vocab terms to describe each of these options. So if you have a system and it has at least one solution, it is called consistent. So if you have a system and it has at least one solution, it's called consistent. And any guesses on what it's called if it has no solution? If one is consistent, what would the opposite of that be? It's inconsistent. Perfect. So I'm going to make myself a little list because, no offense, paragraphs just don't really do anything for me. So I'm going to make myself a list. Consistent is what we say if we have one solution. I don't spell out the word solution either. And then inconsistent is when we have no solutions. So I'm going to put 0 with a line through it so everyone knows it's 0. No solutions. Okay, so those are our first two vocab terms, consistent, inconsistent. One solution, no solutions. But not only can we have one solution, but the solution, and we could have infinitely many solutions. So if it is consistent, then the system can be independent or you're the opposite of independent. You're dependent. Tylen said it first. She gets the point. Dependent. So if you have exactly one solution, you're unique. You're special. So then you're independent. I get lazy and I just put independent. I don't actually spell it out. And if you have infinitely many solutions, you're not special. That one point's not special. So that's why we call it dependent. So again, I'm not really a paragraph person. I like to see it in like a chart list to myself. That way if I made flashcards or something, because vocab's never been my thing, I could study. Independent is one solution. And then dependent is infinitely. So I put infinity sign. It's an infinitely many solutions. But if Nick is super lazy on me and he just puts the infinity sign, I'm going to understand what he means. Okay, so we've got 4 vocab terms. Consistent, inconsistent, independent, and dependent.
That's not that bad.
Okay, so before we even go over number 1, let's talk about the ways these would look with a graph. Because you and I, the learning target says we're solving by graphing. So let's discuss what inconsistent, dependent, what that looks like on a graph. So I'm going to draw myself 3 little pictures over here. Let's see, I got 3 coordinate planes. 1, 2, 3. Okay, so I could have one solution. I could have no solution. And I could have infinitely many solutions. If I had one solution, what 2 vocab terms would I use? Consistent and independent. We're going to put both. Karen, your group gets a point. If I have no solution, what vocab terms am I going to use? Inconsistent only. Ellie, your group gets another point. If I have infinitely many solutions, what vocab terms am I going to use? And you can't do dependent and independent. You can't be both. We're going to say consistent because there is a solution. So consistent and dependent, but I had to help you with that one, so no points for anybody. You got consistent, but you also said independent and dependent at the same time, so we're not going to talk about that blonde moment. We're going to ignore that. Okay, so we're going to graph 2 lines, and we're looking to see where they cross. And where they cross kind of signifies one solution, infinitely many, or no solution. So if, for instance, we have 2 lines, and they cross here at this point, that's what one solution would look like. They crossed at exactly 1 point. That 1 point is our solution. What would no solution look like with our 2 lines? They don't cross at all, which means they are 2 lines that don't cross at all. Yes, ma'am?
Perpendicular.
Is that what you're going to say, Anne-Marie? Well, she raised her hand and everything, so we're going to give her the point. Parallel. Okay, and then this one is kind of tricky, but I think someone can get it. Infinitely many. What would the graphs look like then?
All the same.
Karen, very good. So if we just graphed 1 line and you're like, hey, Paige, you didn't finish the problem. Yes, you did. Infinitely many is like you graph the same line on the top of each other. They are the same person. They are the same line. If you only end up graphing 1 line, you've got infinitely many solutions. Because any of the points on this line is a solution. Any of them. Okay, so, and while graphing sounds great, and you and I love to graph, we're going to learn, after we talk about substitution and elimination, that problems like number 1 would be so much easier if we wouldn't graph. There are so many easier ways. But on this next test and on this next checkpoint, sadly enough, it tells you in the problem. It doesn't say Ellie's name, but it pretty much says, Ellie, solve this system by graphing. Ellie, solve this system by substitution. So Ellie has to understand and know how to graph, even if it's not her favorite way. Okay, so number 1, it's said, and it's hard to see because I've written all over it. X plus 2y equals 6. 2x plus y equals 9. What form are those equations in? I heard it. Yeah, it's standard. You can have a point. It's standard form. They're in standard form. Is it easy to graph in standard form? No. We need to put them in slope-intercept. So I'm going to move over the x. I'm going to have 2y equals negative x plus 6 because I've got to get it in y equals mx plus b. I divide by 2, and I end up with y equals negative 1/2 x plus 3. So that top equation is going to be negative 1/2 x plus 3. So I could go ahead and go over here, go up to 3, 1, 2, 3, down 1, right 2, down 1, right 2, down 1, right 2, down 1, right 2. So if suddenly Paige is questioning her graphing skills, that's going to be a super big problem this section because her graphing skills determines where her solution is. Okay, are there any questions about the gray equation or the gray line? Okay, well, I've got to do math with the other equation as well. It's also in standard form. So if I move over the x, I would have y equals negative 2x plus 9. I don't have to divide by anything. That's pretty easy on that one. The only problem is 9's not on this coordinate plane. So I go up to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. We just kind of have to guess. My slope is negative 2, so down to right 1. Down to right 1, down to right 1, down to right 1, right 1. And I know I'm right because they were both negative, and both my lines, they were both negative slopes, and both my lines lean to the left, so I think I'm right. And I already know the answer from my graphs. What vocab terms should I use? I should say consistent, and I could say independent. And if Cooper, sadly enough, if you forget to leave off the vocab terms, you've not followed directions, because specifically it says in the directions, describe it as consistent and independent, consistent or dependent, or inconsistent. You have to use the vocab terms. So I get that super annoying to have to list that, but you have to do it because the directions said so, and we're direction sticklers. Okay, but where is that one solution? What is that point?
4-1.
Yeah, so we had one solution. It's at 4-1. That's the only point where those graphs crossed. Are there any questions about number 1? Okay, well then let's go to number 2, and they look kind of like a reverse standard form, but regardless, they're not nice and graphable, so we're going to have to move some stuff over. For the first one, if I add x to both sides, I'll have y equals x plus 5. For the second one, if I add x to both sides, I'll have 2y equals 2x plus 8. And now I need to do what? Okay, so how do I need to divide by 2 so I can put it in y equals x plus b. And I'll end up with y equals x plus 4. From here, I already know the answer. I already know the answer from here because of these equations. What vocab terms should I put? And why am I putting inconsistent? Because there's no solution, because these lines are going to be parallel. They have the same slope of 1. They have different intercepts. They're going to be parallel. Now, if it would make HA feel better, of course you can graph 1, 2, 3, 4, 5, up 1 over 1. And I get it did say solve by graphing, so maybe we should graph as well. But if you realize the answer, like, how exciting is that? You didn't have to graph. You already knew. So they're parallel. And again, I totally get Nick just wants to put the word parallel or no solution. But it says in the directions you have to describe it as consistent, independent, consistent, or inconsistent. So we've got to get those vocab terms connected to that parallel no solution. Okay, are there any questions about number 2? I still got people graphing, so I'm going to give them a second. But if you would like to go ahead and flip to number 3, that's where we're headed. It's on the next page. We're only doing 4 today. I see some people still on too, so I'm going to stay here a little longer. Yes, dear. This one? Okay. Oh. Okay, so let's go to number 3 now. Those equations are not in slope-intercept form. They're again in standard form, so I have to rearrange. So for the top one, I subtract 3x from both sides, so I have 2y equals negative 3x plus 12. I divide by 2. I get y equals negative 3 halves x plus 6. Are there any questions about the pink? Then I need to do the same thing for the second equation. So I subtract x from both sides. I have negative 2y equals negative x plus 4. I divide by negative 2. I get y equals positive 1/2 x minus 2. Negative divided by negative is positive 1/2. Positive 4 divided by negative 2 is negative 2. I have a lot of people who keep making sign errors. You've got to be careful, especially in this section with your signs. Okay, and again, I'm a smarty pants. I know. I need to get it together. I already know the answer from these 2 equations. What's the answer from the equations? Okay, I know it's going to be consistent and independent because they don't have the same slopes. They don't have the same intercepts. In fact, one's positive, one's negative slope. So I realize eventually they must cross anyway. So consistent, independent. Am I supposed to figure out exactly where that is? Of course. But hey, I've already followed the directions because all the directions said was to solve by graphing and use these vocab terms. And hey, I did that. Okay, so the pink one I was supposed to put an intercept at 6. So 1, 2, 3, 4, 5, 6. My slope is negative 3 over 2, so down 3, right 2. Down 3, right 2. Down 3, right 2. Down 3, right 2. Do my best to connect those dots. And then for the blue equation, I've got to put my intercept at negative 2. So I put my point at negative 2 on the y-axis. I go up 1 and right 2, up 1 and right 2, up 1 and right 2, down 1, right 2, down 1, right 2, down 1, right 2. And I do my best to connect those dots. But hey, I already realized there was an answer. I see my answer. What point is my solution at? Eduardo was first. Gilberto. Eduardo was first period. Gilberto was first. He can have a point for that. Good grief. Good grief. It's like I'm stuck in first period. Okay, are there any questions about number 3? Now let's practice one more, because practice makes perfect. But I kind of already know the answer to this one. Is anyone, you're allowed to be a genius today. Can you tell from this what the answer is? I can. Can you tell from this what the answer is? What is the answer? It's going to be which and what words we're supposed to use for that. Yes, and how did we know this from this? They're the same. They look like multiples of each other. Okay, so this one, if we, for instance, we could divide by 2, right? And we would have 2x minus y equals 3. If we divide the bottom one by 3, what would happen? What would we get? They are the same. They're the same equation. They're multiples of each other. If you recognize they're multiples of each other, good for you. You're a genius. You probably still need to show some math because it is math class. But good for you. You're a genius. Now, is that what we were supposed to do? No. Is it impressive that we could do that? Absolutely. So I'm supposed to put consistent, dependent. I'm supposed to rearrange them to y equals mx plus b. I'm supposed to solve and be amazed that they're the same line. But at least you recognize that was going to happen. So, let's see. If I go to the first equation, I subtract 4x from both sides. I would have negative 2y equals negative 4x plus 6. If I divide by negative 2, I'm going to have y equals 2x minus 3. So I can go down to negative 3, up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. Down 2 over 1. I connect my dots. I've graphed that top one. Now for the second one, if I subtract 6x from both sides, I would have negative 3y equals negative 6x plus 9. I divide by negative 3. I end up with y equals negative 6 divided by negative 3 is positive 2x. Positive 9 divided by negative 3 is negative 3. So if Paige has a moment and she tries to go graph this line, she's going to put her intercept at negative 3. She's going to count up 2 over 1. And the next thing you know, she's graphed the pink and the green on top of each other in the exact same spot. And Paige is kind of a genius lately, so she probably got this right. But for those of us who've been having blind moments, where would we have gone wrong? Because people have blind moments all the time. Because they get zoned out and all that. Where would they have gone wrong? What would they have done? I'll give you a hint. The mistake they made was in the green, probably. The sign. Negative 6 divided by negative 3, they probably got negative 2. Or they could have made it in the pink. Negative 4 divided by negative 2 got negative 2. So a simple sign error that Tylen makes, and suddenly it changes her whole answer. Because if she had gotten this as a different slope, she would have said they crossed. So the fact that, back to the beginning when I crossed all that out, if you recognize they were multiples of each other, then you know something went wrong because you were supposed to get the same line. So you know, hey, I've really messed up because this was not supposed to happen. Okay, are there any questions about this? It would be genius of you to go ahead and do the 3 problems in the workbook, because that's where I'm just going to add to it tomorrow. I am, but I understand it's homecoming week and last week was so hard, so if you just need 6 minutes to be by yourself, you can.